In this video, we're going to solve some problems that involve expanding logs. We want to expand each logarithmic expression as much as possible and evaluate logarithmic expressions when possible. So we're going to be using the three properties that we discovered in the previous video. The first is that if we have the log of something raised to a power, we can move the power to the front of the log. So going from the right side to the left side here. The second is that if we have the log of two things that are divided, we can break them up into separate logs with subtraction in between. And the third is that if we have the log of two things that are multiplied together, we can break them up into separate logs and separate them with addition. So looking at number 9 here, we have log base 4 of 64 divided by y. Since this is division, it would break up into two separate logs that are separated by subtraction. Now notice that my log here is log base 4. That means that when I break it up into separate logs, those logs will all also have base 4. So we have log base 4 of 64 minus log base 4 of y. Now, log base 4 of 64 is something that I can evaluate further. Log base 4 of y is not. So my goal with expanding is to get it so that each variable or number has its own separate logarithm. And anything where I have log of a number, I can evaluate that. So log base 4 of 64. I could do that on a calculator, or I could think about what that means. Remember, with logarithms, we're looking for the power that we would place on the base to get the middle number. 4 to what power equals 64? Well, you might know that that power is 3. So log base 4 of 64 is equal to 3. And then the other part, I'm just going to copy and paste this here, is going to just come down. So this is 3 minus log base 4 of y. Looking at number 10, we have log base b of x squared times y divided by z squared. So because we have division here, I can break that up into two separate logs that are subtracted. All my logs here are going to be base b. So we have log base b of x squared times y minus log base b of z squared. Now I can break up this log further because I have two things that are multiplied together, x squared times y. So that's log base b of x squared and since x squared is multiplied by y, they break up into separate logs with addition. So log base b of x squared plus log base b of y. The second part, I'm going to again copy and paste it here. Now finally, anything that is a power inside the log can become a number that moves in front of the log. So these squares on the x and the z can move in front of the log. So this is going to be 2 times log base b of x. Plus log base b of y minus 2 log base b of z.